All right, so today we are doing 10.6. We did 10.1 and 10.2 yesterday, and we're just kind of skipping around in this chapter. So we are on today something I think you guys have already learned about. So we're talking about circumferences and arcs today. Everybody with me? I feel like I don't have some eyes. Gentlemen in the back? Yeah, okay, can you do that outside my class? Can you stare up with the TV? Awesome. I'm so glad that's recorded for everyone to listen to later. All right. I'll just cut this out. We'll see. We'll see how much I care about it later. No, I'm not that great at editing silence. Now all of you have to listen to a 2-minute intro where I tell them to stop staring at each other. So, all right, now that we're finally going to get started, circumference is what we're going to focus on today. But before we get to that, we're going to talk about something called the arc. I like to think of the arc as the pizza crust. I think he is too. I really hope the added audio catches that up. That pizza song was pretty great. Okay, so I think of arc like a pizza crust because it's the edge of the circle that doesn't have any of like the insides, any of the toppings, any of the stuff like that. It's the outside that we can measure. If I could take a like string and wrap it all the way around the pizza, that's where the crust would be. That's how big the circle is. That's my circumference. The arc is just part of that. So there's a couple different types of arc. One is a semicircle, which is exactly half of the circle. And then there's two other types of arc. They're major arc and minor arc. We're going to talk about the minor arc first. Minor arc, you only need 2 letters to represent that, and it's the shortest distance between those 2 points on the circle. You only need 2 letters. And again, it's the shortest distance. You use the 2 letters and then like this little curved line over it to represent that it's an arc, not a line, not a segment, not anything else. Minor means that it's smaller than a semicircle. On the other side, we've got a major arc, which you have to use 3 letters to represent. 2 of them are the endpoints that you're starting at and that you're ending at. So like S is where you start, R is where you end. And then T is another point on the arc that you have to hit. So I go from S towards T and I go all the way to R to finish. And this one you have to use 3 letters. You also need to use 3 letters when it's a semicircle as well. So a minor arc, you can use 2 letters to write. A major arc, you need 3 letters to write. A minor arc, you only need 2 letters. A major and a semi, you need 3 letters. Okay, now that we've talked about arc, we're going to talk about arc measures. Arc measures are in degrees. In degrees. The arc measure comes from the central angle that's inside my circle. So I'm going to zoom in on my circle. I'll zoom back out momentarily. But the central angle is if I go like from the center of the circle and I connect like the angle between the 2 radius that make that piece of pizza. I'm essentially taking my piece of pizza and measuring what the angle of like the end of it is. So in this case, I've got 50 degrees as my central angle for RST. That means that the measure of my arc right here at RT is also 50. It's just the exact same. There's more rules. We're really not getting that deep into it, but a very basic rule, central angle is the same as the arc measure. So that's 50. Does anyone know how much it is for a full circle? What would it be if I did the entire circle in degrees? 360. Very good. So a whole circle is 360 degrees. That being said, could I find out what the arc measure of arc TQR is, that blue arc? Yes. Ava, how would I do that? I do 360 minus 50 because I'm using all but that 50 degrees. So 310 is the arc measure for TQR. The other thing to note before we move on is the arc measure of a semicircle is 180 degrees. 180 degrees. All right. Questions yet? Let's do a few examples of these, shall we? So I'm looking at this picture right here. It says circle O. Do you see this notation right here? This means circle O, and I use a circle with a dot in it so you don't think it's 0 or O or anything else crazy. AC and BD are diameters. Okay, time out. What's a diameter? Who can describe a diameter? Not necessarily like a math definition, but like what does it mean? Max, what does it mean? Good. One side to the other side, and it has to pass through the very center. So it goes through the center and it goes from one end to the other end. It's like the fattest part of the circle. If I went to the widest part of the circle, that's the diameter. Anybody else have other words to think about with diameter? That's good. Oh, Ava? Yeah, radius is half of the diameter. Good. That's a good thing to think about. Very good. All right, let's do some of these. So now it's talking about arcs, and it wants us to find the measure of all these arcs, so a measurement in degree, and decide if it's major, minor, or a semi. First one is AB. What's my measure for AB? 44. Why, Silas? It matches the central angle. Yes, very good. Central angle. Now, is 44 a major arc, a minor arc, or a semicircle? Minor. Why minor? And it only has 2 letters. Very good. So a couple good things there. I heard that it only has 2 letters, which means it has to be minor. The other thing is I heard it's less than a semicircle. Perfect. All right, next is DA. It doesn't matter which one I go to and which direction I go to. I'm just still doing the shortest distance from A to D. So I'm going here. All right, thoughts on how I can find that? Maddie? Why 180? Half the circle. So Maddie says that from B to D would be a whole half a circle. So she's going to take off the 44 that we're not including and find out that this DA is 36 degrees. And is that major, minor, or semi? It's not semi. It's minor. What does it have to be semi? Also, what else? What'd you say? Yeah, Cindy? 180. 180 is a semicircle. There we go. That's what I was looking for. Perfect. Okay. What about the next one? BCD. Let's find that. So this one has 3 letters. I start at B, I end at D, and I have to hit C in the middle. So I'm going to go from B to D, but I have to hit C in the middle. All right. What are we thinking? Charlie? Yep. Why? It's a semicircle. Okay, that was the next question I was going to ask. And why do you know it's a semicircle? Don't say 180. Anyone want to help him out? Sydney? BD is what? 1 line. Yes. Ava, what else? It has 3 letters. Good. That doesn't make it a semicircle, but it helps us know. It's a straight line that also doesn't make it a semicircle, but it helps us know. I'm looking for like one more specific thing. Anyone know what the specific word I'm looking for, Abby? Diameter. A diameter is what splits it in half. And so since BD is a straight line, it is specifically the straight line that is the diameter, which makes it cuts it right in half, makes it a semicircle. All right, got 2 more of these. BC. That's the smallest distance from B to C. What do we know about that one? Ava? Why do you think that? Good. You almost said something I wanted, but not quite. You said opposite angles are congruent. I didn't want to say that. Cindy, what do you want to say going off of that? Vertical. That's what I want to say. So these are vertical angles. I taught you that day 2 or 3 of geometry. We're still using it. even though they're inside the circle, because these angles are congruent, that makes their arcs congruent across from them too. And if BC is 36, is that major, minor, or semi? Anybody? Minor. Very good. All right, last one is ACB. So I have to go to A to B, but I have to hit C in the middle. So I'm going to go this way. Go in the long route. Cyrus? It's 316. And how did you get 316? Good. So Silas told me it was a major because it's more than half of a circle. He knows the entire circle is 360, but he's not using this little bit right here, 44. So it's 316. Someone earlier today said that to me, and I thought they said 360 because 316 sounds a lot like 360. So I'm trying to be over enunciative with it. 316, and it is major. All right, good work. Any questions yet? All right. This next part's really basic. It's talking about adjacent arcs. It looks like something that should be a vocab word, but those are just two words you know sit next to each other. Adjacent means next to, and it also means they just share exactly 1 point. They don't overlap like a segment. They only share 1 point. So like here, AB would be adjacent arcs to BC because they only share point B. That's all I got for you. Any questions, any thoughts? All right, turn the paper over. We got 2 formulas on the back side. Need some water, though. Okay. We're going to do circumference next. You guys have learned circumference, right? This is easy. This is like kid stuff right now. I was telling the other class, this is like the part of geometry that like you probably thought we were going to do all year. And then you're like, what is this crazy stuff we've been doing, Miss White? This is the easy stuff you've been waiting for. So like, let's really knock this out of the park this last quarter. Circumference is either pi d or 2 pi r. I'm going to teach you about area tomorrow. Area is pi r squared. Sometimes I get confused because I'm like, oh, well, area and circumference both have a pi, they both have an r, and they both have a 2. The reason I keep them straight is I remember that area is like feet squared or inches squared or something squared units. So the square goes in area, not in circumference. You don't need that today, though. We'll do that tomorrow. Everybody with me? Well, whatever the next time I see you. Not today. Next time I see you, you'll need to know it. All right, next shape. I'm going to do 3 examples of circumference. So I've got a square with a circle in it. What's going on? The diameter is 11. If this is the length of one side of my square, I can move this wherever, and it's the length from the top of the circle to the bottom of the circle, and it goes right through the middle. So this is my diameter. Diameter equals 11. Now, I want your answer to be exact and simplified, which means I want it to be a fraction, not a decimal, and I want it to not be a decimal. I want it to have pi in it. So I'm going to have an answer that's just 11 pi yards. That is the best answer. Don't do 11 times pi in your calculator. I only want 11 pi yards. Everybody hear me? Don't put pi in your calculator. Yeah, you do actually have to go. All right, next one. Do I have the diameter here like I did last time? No. What do I need to do to find it? Pythagorean theorem. I need to find my hypotenuse. You can call it x. I'm going to call it d because it's going to be the diameter once I find it. 5 squared plus 12 squared equals d squared. 5 squared is 25. 12 squared is 144. I don't know, bud. I don't go to school here. Silas says yes. I'll just tell him yes. I don't really care. You guys are so cute. I don't know any of your procedures. They changed everything, Maddie. Yeah. You think the school looks the same after 10 years? You guys barely have a uniform. They were race dirt drawn uniforms. We didn't walk out of the classroom without a pass. Like, the school has gone way soft. Not that that's bad, just as true. 25 plus 144 is 169. And then square root both sides, and I get 13. So diameter is 13. If diameter is 13, what's my circumference? Good. Centimeters, good. I love that we added centimeters in there. 13 pi centimeters. All right, one more circumference problem, and then we're going to add one more thing. Only for area. Great question. Think of circumference like perimeter. So I like to think of circumference and perimeter are the same. So there's no square with a perimeter, no square for a circumference. All right, last shape. What should I do to solve this? Ava.
So you know that the legs are going to multiply by root 2. And 40 multiplied by root 2, but I just multiply by root 2, which is easier.
What method is this?
This is a special right triangle with the 45, 45, 90.
Good. So Ava's telling me that you can just multiply by root 2 because it's a 45, 45, 90. She knows that because root 2 and root 2 are my legs. So root 2 times root 2 is root 4 or just normal 2. So my diameter is 2. Circumference is 2. Good. Anyone want to add to that process or do it a different way? You could have also done Pythagorean theorem. That's totally okay. And there are some days that I don't see the special right triangle and I see Pythagorean theorem, and some days I see the special right triangle. So either way is fine. All right. The last skill that I need to teach you deals with the fact that we've been talking about an arc all day. The arc is a part of a circle, and we talked about its measure, but now we're going to focus on its length. Its length is a part of the circumference. The length of the arc is part of the circumference. So think of circumference again. If I take a string and wrap it all the way around this ball or around this circle or around this pizza, whatever you want to call it. If I have like a piece of pizza, I don't eat the entire pizza. I just have like one piece. So my arc length, I cannot measure a straight across line like we would like in distance because it's curved. Instead, I'm going to think about it in this way. I'm going to think about it as the length of the arc is the fraction of the circle that we're looking at times the circumference. We're essentially just saying, okay, well, if I have a piece of pizza that's like a fourth of the pizza, then I can take the whole circumference and just do a fourth of that. Circumference we know is either 2 pi r or pi d. I like to write both down just so I have them both. And then the fraction of the circle comes from here. It's going to be based on angle measurements. So it's going to be the central angle divided by all of the angles, all of the degrees. What's the total number of degrees in a circle? 360. So 360 is always in the bottom. And then the measure of my central angle is on top. In this example, I'm going to write AOB because that's physically what it is, AOB. Now, this is not in degrees like the measure was. Arc length is in like feet or inches or like an actual unit. And so I'm just going to draw an arrow to the little box that says arc length is in units, inches, centimeters, yards, kilometers, etc. All right, questions yet? You might need a little bit of help to do a couple examples first. So I'm going to do these examples. I'm going to use this circle O that I have, find the length